Hello everyone, welcome back to our channel. Today we're diving into the world of calculus and exploring the derivative of the sine function, sine x and sine inverse x. Let's get started. To find the derivative of sine x, we'll embark on a visual journey using a unit circle. Imagine a unit circle with a radius of 1 unit where the hypotenuse subtends an angle of x radians. The opposite side, denoted as AB, corresponds to the value of sine x. Now, let's increase the angle by a small value dx, leading to a new side, CD, representing sine x plus dx. To isolate the change, MC, we turn our attention to the arc length, which, for small angles, approximates to a straight line. This arc length, equal to dx, since arc length is equal to the radius times the angle subtended, is represented by the line CA. For a small change in the angle, the change in sine x is equivalent to the cosine component of the arc length given by the line MC. To find the length of MC, we start with the base angle AOB. The angle MAO is also equal to x since they are alternate angles, and since angles CAM and MAO are complementary, being between the radius and tangent, angle CAM is equal to 90 minus x. Therefore, the required angle MCA is equal to x. Consequently, the cosine x component of the arc CA constitutes the length of the change in the sine x side. By further simplification, taking the ratio of the functional change to the angular change, we get the derivative of sine x to be cosine x. Moving on, let's explore the derivative of sine inverse x. Sine inverse x performs the inverse operation of the sine function, taking the value of sine and returning the corresponding angle. Now, to find the derivative of sine inverse x, first, we change the angle notation from x to theta, as x generally represents the independent variable, and here the independent variable is the sine component and not the angle. Therefore, we replace the angle with theta in all other terms accordingly. Assigning sine theta as x, the change in sine theta represents dx. Using the Pythagorean theorem, we express cosine theta as the square root of 1 minus sine squared theta, or the square root of 1 minus x squared. The dependent function, d theta, is defined as d sine inverse x. To find the change in angle in terms of x, we notice that dx is the cosine component of the arc CA. Hence, we rearrange this equation for d sine inverse x. The final result, obtained by taking the ratio of the sine inverse function with the change in x, yields the equation for the derivative of sine inverse x. And there you have it, a visual proof for the derivative of sine x and an exploration of the derivative of sine inverse x. Understanding these concepts opens the door to a deeper comprehension of calculus and its applications. If you enjoyed this video, don't forget to like, share, and subscribe for more engaging content. Until next time, happy learning!